Assalamualaikum and good day everyone. My name is Mahazir A. Sanda, BSc 2A. So for today's video, I will discuss to you the elementary knowledge on symmetry elements of crystallographic system, which is belong ito sa mineralogy na reporter number 2, batch number 2. So first, let us define kung ano muna ang mineral and mineralogy. Mineralogy is a subject of geology specializing in the specific study of the chemistry, crystal structure, and physical properties of minerals and mineralized artifacts. Specific studies within mineralogy include the processes of mineral origin and formation, classifications of minerals, their geographic distribution, as well as their utilization. So the mineral is a naturally occurring inorganic elements or compound having an orderly internal structure and characteristic chemical composition, crystal form, and physical properties. Common minerals include quartz, feldspar, mica, amphibole, olivine, and calcite. So ito na ang symmetry elements of crystallographic system. The locations where the symmetry operation occurs, such as a rotation, axis, a mirror plane, an inversion center, or a translation vector, are described as symmetry elements. So there are 7 primitive crystal systems. Una na dyan is isometric or cube. All 3 axes are equal in length and all are perpendicular to one another. This is the figure in the right side. Next in line, tetragonal. 2 of the 3 axes are equal in length and all 3 axes are perpendicular to one another. Orthorhombic. All 3 axes are unequal length and all are perpendicular to one another. Hexagonal. Of 4 axes, 3 are equal in length and separated by equal angles and lie in the same plane. The 4th axis is perpendicular to plane of the other 3 axes. Hexagonal cells have lattice point in each of the 2 6-sided faces. So this is the figures. Sa right side nyo lang makikita ang mga figures. Next is triclinic. All 3 axes are unequal in length and none is perpendicular to one another yan. Monoclinic. All 3 axes are unequal in length and 2 axes are perpendicular to another. Rhombohedral or trigonal. All 3 axes are of equal length and none of the axes are perpendicular, but the crystal faces all have the same size and shape. How are minerals identified? So mineralogists are scientists who study minerals. One of the things mineralogists must do is identify and categorize minerals. While a mineralogy might use a high-powered microscope to identify some minerals, most are recognizable using physical properties. In crystallographic, symmetry is used to characterization crystals, identify repeating parts of molecules, and simplify both data collection and nearly all calculations. Also, the symmetry of physical properties of a crystal, such as thermal conductivity and optical activity, must include the symmetry of the crystals. So, kanina na yan. Naulit lang. Ito, color kung paano ma-define yung minerals. So, color, streak, and luster. So, define natin yung tatlo. Okay. Color is often useful, but should not be relied upon. Different minerals may be the same color, real gold, as seen in figure number 2. So, this is figure number 2. Is very similar in color to the pyrite in figure number 1. So, saan ang figure number 1? Char. Baka nakalimutan ko. Additionally, some minerals come in many different colors. Quartz, for example, may be clear, white, gray, brown, yellow, pink, red, or orange. So, color can help, but do not rely on color as the determining property. Figure number 3 shows one sample of quartz that is colorless and other quartz that is purple. A tiny amount of iron makes the quartz purple. Many minerals are colored by chemical impurities. So this is yung sinabi kanina na figure number 3. Luster describes the reflection of light of a mineral surface. Mineralogists have special terms to describe luster. One simple way to classify luster is based on whether the mineral is metallic or non-metallic. Minerals that are opaque and shiny, such as pyrite, have a metallic luster. Minerals such as quartz have a non-metallic luster. Streak is the color of a mineral's powder. Streak is a more reliable property than color because streak does not vary. Minerals that are the same color may have a different colored streak. Many minerals such as the quartz in the figure number 3 do not have streak. Specific gravity. Density describes how much matter is in a certain amount of space. Density is equal to mass over volume. Mass is a measure of the amount of matter in an object. The amount of space an object takes up is described by its volume. The density of an object depends on its mass and its volume. For example, the water in drinking glass has the same density as the water in the same volume of a swimming pool. Hardness is the strength with which a mineral resists its surface being scraped or punctured. In working with hand sample without specialized tools, mineral hardness is specific by the Mohs hardness scale. So this is Mohs hardness scale sa right side. The Mohs hardness scale is based 10 reference minerals. From talc, the softness, it is a relative or non-linear scale. A hardness of 2.5 simply means that the mineral is harder than gypsum and softer than calcite. To compare the hardness of two minerals, see which mineral scratches the surface of the other. So, you can post the video kung gusto nyong screenshot, Char. Basta ito yung table sa right side. Next is cleaver and fracture. Breaking a minerals breaks its chemical bonds. Since some bonds are weaker than other bonds, each type of mineral is like to break where the bonds between the atoms are weaker. For the reason, mineral breaks apart in characteristic ways. Fracture. Fracture is a break of in a mineral that is not along a cleavage plan. Fracture is not always the same in the same mineral because fracture is not determined by the structure of the mineral. Minerals may have characteristic fracture. In figure number 6 later, yung figure number 6, metal usually fracture into jagged edge. If a mineral splinters like wood, it may be pervious. Some minerals such as quartz from smooth curved surfaces when they fractured. Crystal shape. All minerals are crystalline, but only some have the opportunity to exhibit the shapes of their crystals. Their crystal form. Many minerals in an introductory geology lab do not exhibit their crystal form. If a mineral has space while it glows, it may form natural crystals, with a crystal shape reflecting the geometry of the mineral's internal crystal lattice. How crystal defines? So kanina mineral, kung paano i-define yung minerals. So ngayon, crystal naman. There are six crystal system. So yung 6 crystal system is yung nabanggit natin nung una. Or 7 yun, 7. All minerals form crystal in one of these 6 system, although you may have seen more than 6, so 7 nga, shapes of crystals. There are variation of one of the 6 habits. Each system is defined a combination of 3 factors. 4 factors pala. How many axes it has. Number 2, the length of the axis. Number 3, the angles at which the axis meets. And the number 4 is an axis is a direction between the side. The shortest one is A, the longest is C. There is a B axis as well and sometimes a D axis. So, paano i-define yung isometric system? The first and simplest crystal system is isometric or cube system. It has 3 axes, all of which are the same length. The 3 axes in the isometric system all intersect at 90 degrees to each other. Because the equality of the axes, mineral in cubic system are singly refractive or isotropic. Minerals that form in the isometric system include all garnets, diamonds, fluorite, gold, lapis lazuli, pyrite, silver, sodalite, sphalerite, and spinel. So, ganito identify ang isometric system. Second is tetragonal system. Tetragonal system also has 3 axes that all meet at 90 degrees. It differs from the isometric system in that the C axis is longer than the A and B axis, which are the same length. Minerals that form in the tetragonal system include apophyllite, iodocrise, rutile, scapolite, fulvinite, and zircon. Orthorhombic system. In this system, there are 3 axes, all of which meet at 90 degrees to each other. However, all the axes are different length. Minerals that form in the orthorhombic system include dolosite, celicite, chrysoberyl, corderite, iolite, danborite, zoisite, tanzanite. Basta ito yung mga sample sa baba. Next is monoclinic system. The previous discussed crystal system all have axis sizes that meet at 90 degrees. The monochromic system, 2 of the axes, A and C, meet at 90 degrees, but B axis does not. All axes in the monoclonic system are different lengths. So, ang example is nasa baba. Kayo nang magbasa. Next is triclinic. In the triclinic system, all the axes are different none of them meet at 90 degrees. So, pwede nyo i-pause para makita nyo yung examples. Hexagonal system. The crystal system previously discussed represent every variation of four-sided figure with three axes. In the hexagonal system, we have an additional axis, which gives the crystal six sides. Three of these are equal in length and meet at 60 degrees to each other. The C or vertical axis at 90 degrees to the shorter axis. Nasa babang examples. Next is trigonal subsystem. Mineralogy sometimes divide the hexagonal system into two crystal systems, the hexagonal and the trigonal, based on their external appearance. However, for gemological purposes, the above six categories are sufficient. So that's all for this video. I hope na may natutunan kayo kahit konti. Once again, my name is Mohazir A. Senda, reporter ng Elementary Knowledge. Basta yun. Wasalam.